How many of you build robot, line follower robot, or any kind of robot? How many of you build? Can you please ping me in chat? How many of you build robot, or how many of you build any kind of Arduino project, or like that? Yeah, Wilson. Anyone else build any project using Arduino, or anything related to robotics, like line follower robot, object detection robot, or obstacle avoiding robot, any kind of that? Yeah, bionic robot made. Oh, cool, cool. Anyone else? Oh, chatbot or line follower robot. Oh, yeah, cool. Oh. Yeah, I also I would like to ask another question too. Which part was the major toughest part and major toughest part when you build the robot? When you're writing the code or building the hardware or designing the robot, or which part is the most toughest part to you, and which is the most easiest part to you? Can you please ping in chat? This is the most easiest part when you build a robot. It's designing, assembling the robot, assembling the robot using Lego kits, or writing the program using Arduino. Which is the most easiest part, or which is the most toughest part to you? Interfacing the most of the time. Yeah, okay, interfacing. Okay. Yeah, that's it. Anyone heard about ROS? Anyone previously heard about ROS or read anything about ROS in Google? Yeah, okay. Okay, cool. Yeah, first of all, I would like to start with how, just end my slides now. Yeah. First of all, some of you someone says that he was challenging at the stage of interfacing all the thing. Like I think he's telling about program interface or hardware interface. Whatever it is, I will tell. Yeah. What is ROS? It's a big question. Yeah, right. Everyone is building a robot, building hardware, building automations, everything, right? The main important thing is in the ROS is it is open source, and we can build anything on top of the available packages like that. And ROS is a meta operating system, and it is performing on the top of another operating system. And everyone think that it's an operating system, want to download it and want to work on that. It's not like that. We can install ROS on top of our Windows, Linux, Mac, or anything. But Ubuntu have more support for ROS, and there is various versions for ROS by solving many challenges like that. And why then? What is ROS is? It's a meta operating system. It consists of loads of library, loads of packages that are written by many other people or many collaborators. In each and everyone can use that particular libraries, packages for building their robot too. Okay. Yeah. We can in that we can say that it's a huge mountain of libraries, programs, packages, etc. Yeah, that's about a simpler explanation of ROS. Yeah, then everyone is thinking that why I'm using it, why I want to use ROS, right? Some of you said that he has challenge in interfacing something. I think he said that interfacing the software side. I'm considering that particular thing. If I'm interested in building a robot and I don't know anything about coding, I don't know anything about designing, I don't know anything about what happened in the real world or how my robot is going to perform in real world after I building that. All this problem can solve by ROS. If I don't know anything to write program, I don't know C, I don't know C++, I don't know Python, I don't know any sort of languages, but I know to read some documentation, right? Those guys are interested in reading documentation or reading tutorials will help to learn ROS. Like if I'm a guy, I'm just going to explain my case. I'm interested in reading books, reading blogs like that. And in my 12th standard, when I'm 12th grade, in my age of 18, and now I'm 21. In my age of 18, I started learning ROS, but I don't get any proper documentation or like that. When I go to search in ROS Wiki is a platform for official ROS documentation. When I go to search ROS Wiki, how I can learn ROS, how I can start it, but I can't grab anything from that, because the all documentation is like there's no any after we acquire the prerequisites, then only we can read that particular documentation. Then only I can understand that particular documentation. So I go in search of many course like that. At that time, I heard a course about a 1 week course on ROS that conducted by IEEE in our section. So I participated in that particular session for 1 week, and I got some basic idea and some basic concept of ROS in my age of 19. After that, I started learning myself. I got a small get starting thing, like a session like this, how we can learn ROS, what is ROS, how I can work on ROS, like that. Initially, I said that ROS is a meta operating system. It's a mountain of libraries, packages, programs, and etc. etc. Then I go into why ROS, why we are using ROS. Why we are using ROS is because if I don't know, I'm not mastering programming, I'm not mastering designing, and like that, I can source some files that already in the GitHub repository that by ROS. I can contribute into ROS. You can each and everyone can contribute into ROS for like a collaboration for to build that community huge like that. So many of them are writing ROS libraries, ROS packages like that. And also, I would like to reveal one thing. Soon I will be publishing a ROS packages for Cdino. I'm working on that, but it's not completed, and it's in starting stage. I would like to share to that. Okay, why ROS is because we have a lot of other things, lot of packages, libraries, and etc. etc. Also, I would like to share a small meme to understand what exactly ROS is. I written a documentation about ROS. I'll share after this session to you all. Why ROS is anyone can share what you get from this particular meme. This one guy is showing a round wheel, and another guy is saying that no thanks, we are too busy, like that. And that guy said that no thanks, they are using a square type wheel, right? And another guy is showing a round type wheel. Anyone can infer anything from this, and what exactly they mean with this particular meme? Anyone can put in the chat what exactly they mean. What exactly this guy is saying that in this meme? Anyone can? Yeah. This exactly mean that why we are using ROS. One guy is saying that we are too busy with pulling off that cart, and another guy is showing that I have a round type wheel. This will help you to pull that cart easily. But that guy is saying no thanks, we don't want this, like that. Yeah, that's right. They don't want to improve the current system. Yeah, that's right. Actually, we all are writing. We want to experiment. Yeah, right. That's right. Yeah. And everyone is going to build their programs, their hardware from bare itself. But but in the case of ROS, there is lot of packages, lot of libraries that's available in GitHub itself. So we don't want to build any kind of program from bare, or we don't want to hard code from scratch itself. And it make us easy to perform each and every task. And we only want to focus on what our innovation is and what we are doing is, what our aim is. We don't want to focus on how we are actuating our wheel, and we don't want to focus on how we are controlling our differential drive robot, or how we are going to control our skid steer robot. We don't want to bother about anything of that. And that's everything is still available in ROS packages itself. So we only need that only want to source that particular library and add on to our project. That's exactly why we are using ROS, because it's save our time, it save our work experience, it save our lot of working time, and it give some sort of learning tool when we goes to higher stage of that. And we don't want to work on like reinventing wheel. This is a bad example for that. We don't want to reinvent a wheel. We can use the existing wheel for to our robot, our system. That's what basically this mean. We can source that particular file. I would like to say an example. When I started building a robot in ROS, it basically it's hard for me. I don't know anything. I don't know how I want to source. I want to do this everything. And I got some documentation. I go through that session, everything. After that, I learned that I want to control my robot using my keyboard arrow key, or keyboard some keys using my keyboard. There is a library for that in ROS that called teleoptist keyboard. I don't want to write that code from there in Python or C++ to actuate my robot. That's an easier and simpler thing for me. And I can simply source that particular file and I can use that in my robot. And I can save a lot of time. And at that time, I can learn another thing, like how I can how I can incorporate much innovation into my robot like that. I don't want to waste my time. This is a great example that I see in Google. Don't want to pull the card using square wheel. There's an existing round wheel. It will be easier for us to pull that card. Exactly a dicto in the case of ROS. There's a lot of library, lot of packages, and lot of tools are available still in ROS, and we only need to use that into our robot. That's it. Yeah. If anyone have any queries that you can ask in the chat box, I will answer in minutes. Yeah, I say ROS is simpler, and how we can learn ROS. How ROS is working. Why we are using ROS like that. How many of you think that building a robot is too hard? How many of you think that building a robot is too hard? Everyone seems that it will be easy. Yes or no? Can you please put in the chat box? How many of you seems that building a robot is too hard? Am I audible, right? Hello, am I audible, right?
Yeah.
Yeah, okay. How many of you build robot from scratch? I think the hard when the most of or actually I think it's hard.
Yes, we need to accept challenge.
Yeah. I think it's hard. We have most. Okay. Yeah, we need to accept the challenge, right? Yeah, but we in that particular time, if we are building a robot from scratch, it will be too hard. Like sometimes I made line for a robot. Okay. Yeah. If you are building a robot from scratch, if we want to invest more time, want to invest our productive time to from basics, like want to build the wheel, want to build it. That I said, we have some keyboard control that are available in the ROS. That's a small library. And similar to that, we have a lot of library. I will explain at the end of session which are the libraries are easily available, and we can easily use in our robot like that. Yeah. Well, yeah. Actually, when we are building the robot from basics, it will take a lot of time. And I would like to explain in between. I would like to explain a small thing that I experienced in last day when I go for a hackathon. I go for a hackathon and I participated in it, and Salman helped me a lot for that hackathon. Thanks for that in video session. Also, when I'm participating after the 24 hours of hackathon, I built a small prototype and went to the judges, and they asked me that this all things are available, and this all that you build is easily. And when I show the first prototype of my product, it basically collecting the data and pushing that everything to a dashboard. At that time, the judges says that This is too easy. Anyone can build this. What is your innovation? Similar to that, if I use that available programs in Google, it will be easier for me to do the innovation and innovative thing in my product. That will help a lot in my presentation itself. Similar to that, we have available, we already available lot of libraries packages to control our robot, and we only want to focus on what innovation we are doing on the robot. On top of that, so it will be more time saving. It will be more curious to other when they see our robot like that. When it comes to the prerequisites of the ROS, everyone think that I want to be a pro in programming, pro in designing, pro in manufacturing, pro in electronics. None of that mandatory. You only need is some basics in Python and some basics in Linux command line, or some basics in command line. That's it. How we can source a file, how we can access a library through command line terminal, and we also we need some basics in electronics, like how we can interface to sensors, how we can interface to modules, like that only. And we don't want to be a master in programming. We don't want to be a master in software. We don't want to be a master in electronics, like that. Everything is available in Google, and everything is documented by ROS itself. If we have some prerequisites like this, and basics in Python, basics in C++, basics in electronics, basics in design. That's it. That's enough for learning the ROS. I'm not a pro in everything, and I do build a robot in ROS in my school days. And when I'm in between the gap between the school days and my college days, it's too easy to build a robot using ROS. And once again, I'm repeating the prerequisites. A little bit knowledge in Python, and a little bit knowledge in C++, and C++, and a little bit knowledge in Arduino, and a little bit knowledge in design. That's enough to get started in a robotic platform like ROS. Else everything is available for free, and we can innovate on top of that, and we can contribute into that open source community too. Yeah. Next big question is how our ROS robot is going to work. That will be a big question to everyone, right? Anyone can explain how? I would like to. Just a moment. I'm just going to the chat. Anyone can explain any of the robot, how it works, like that? Some of the guys said that they build robot using a line follower robot, obstacle avoiding robot, like that, object detection robot, like that. Anyone can explain the workflow and how does it work? How it work in a real scenario? Yes, following the program comments. Okay. Sorry, I don't get you, Salman. Can you please? What exactly you mean? How anyone can explain how the robot is going to work like that? I mean, yeah, right. Yeah. If the yeah, right. Yeah. That's it. That's the thing I want to get. The program the robot using based on sensors. Both Salman and I don't know to pronounce Siddiq. Both are saying the right thing. Yeah. We have a lot of sensors, a lot of actuators, a control, a master control is there, right? Like that, robot is working in a sound following. Oh, cool. Can you please explain, Susmita, how it works?
Hello, everybody. I'm Sushmita Das from India. Okay, so I have made this sound follower robot. So in this case, I have fixed one sound source, and there I have fixed one particular frequency of that sound, and that will be captured by the microphone that was present in the that sound follower robot on that chassis. And
Yeah, okay,
that
cool.
chassis will continuously follow that sound, that particular frequency, and it will reach to that sound source. That is the main function.
Yeah, okay.
That's why I've called it as the sound follower robot.
Yeah, okay, cool. Thanks for your sharing experience and your robot. Yeah.
Thank you.
In Susmita's robot, it is like we have a source that making sound, and there's a microphone that capturing the sound. And in the case of ROS, these both are nodes. It's capturing the data from this particular speaker or buzzer, and this node is pushing that data into their controller. And based on that data, it controls the actuators. That's Smita is going to explain in last minute when it comes to the aspect of ROS. And it's a nice project, and I would like to thank him for sharing experience and its robot. I just explained. Is my screen is visible, right? Is my screen is visible, right?
Yeah.
Yes, sir.
Okay. I would like to take the example of the Smita's robot, and there's a master. Is controlling everything, and is controlling each and every node and each and every topics that's in ROS. It's a basic architecture of ROS, and how ROS is to work, we can explain using this particular diagram. How many of you use MQTT and PubSub for building robots? How many of you build MQTT protocols for building the IoT project? Those guys can easily capture this particular thing. How many of you made a project using MQTT? Long time ago. Okay. Yeah. Okay. Anyone else? It's space robots. Yeah. Oh yeah. Okay. Yeah. Basically, this working exactly ditto to the MQTT protocol. Not exactly ditto, but a little bit changed in the architecture itself. I explained from the beginning. There's three guys. These are two friends. This is two friends, and this is his teacher, and his teacher. The teacher is taking class, and this student can't able to talk with his friend, and because the teacher is taking class. So for to solve that problem, teacher asked this student, what do you want to tell his friend? Like what message you want to transfer to your friend? So similar to that, there's two nodes in the right side and left side. The master is a teacher. Both nodes are students. Yeah, and similar to MQTT. Yeah, both nodes are students. Just consider both. I'm explaining this for those who don't know about MQTT like that, and just starting with the basics itself. Both nodes are two students, and the master is a teacher, and a teacher is taking class. So at that time, both students can't able to talk each other, because sometimes teacher must call both of the student and get out and fire out them out of the class. At that time, teacher said that ask the node one, what do you want to say to the node two? Like ask friend one to friend two, what message you want to transfer to this guy? That means the node one is publishing a data to the master. To the master means to the teacher. One student is transferring his messages to master, to the teacher, in a particular topic. Like particular topic, for example, I'm writing in a paper X is a message name. For example, I can only I would like to explain another term. I know English. Some of all the guys know English, and I don't know Chinese, and some of them don't know Malayalam. Some of guys don't know Hindi, like that. And our only known language to everyone is English, right? So I can only talk in English to all you guys. Then only you guys understand my language. Otherwise, you didn't get my language, right? Similar to that, the node one is writing a text to the master in a particular topic. Topic means a tag name. For example, it's a language, but it's an analogous example similar to that, but communicating based on a topic. Topic is a unique name or a unique identity. So topic is a unique identity. Based on that, node one, student one is transferring a message to master. And at that time, the node two, that means the student two is eagerly waiting for to get what his friend says, want to know about what his friend says, like that. He's eagerly waiting for that. At that time, the node two, that means the student two is asked to ask the teacher or ask the master what the student one tell to him. And that want to be a similar topic, right? Then only the student two can understand. Otherwise, the student didn't understand. And every every student want to say similar language. Otherwise, they didn't get that. Like that, similar to that. So the node one is a node one, node two, and another is a master. Master is a bridge between node one and node two. And it's the only way to connect node one and node two. There is no any other way to connect the node one and node two. If they are connected each other, at that time, they get their anxiety to talk each other. Similar to that both students are excited to talk each other. At that time, they remove their master and they will start to talking each other, like in that particular topic. Like they get a connection, so they can talk each other based on that particular topic. Because if I understand what my friend is going to say, and I can easily capture that particular thing, even if he didn't talk and if he say everything using his sleep, I can easily understand what exactly is going to tell what next. Similar to that, even both nodes get connected, they will avoid the master and they will start communicating each other. Similar to that, this is a working of ROS. I would like to explain in the case of Susmita robot. Like it's like we have a master that's for sake of my demonstration. I would like to say that it's a Jetson Nano. Susmita's robot master is a Jetson Nano. One node is capturing data. That's a microphone. Another node is actuating wheel. Microphone is capturing the data where the sound coming from, and where's the most frequent sound that coming from to the master that Jetson Nano. The node that advertising is microphone. The master is Jetson Nano, and the node that subscribing the data is wheel or actuator. If I get most frequent sound in the right side or left side, whatever it is, and the node is saying that I get much sound from this side, so that node push the data into the master, and master say master have the data. At that time, the wheel is asking to where the exact sound is coming from, and based on that, the wheel can actuate that particular sound source. That's if both wheel and sensors get connected, and then they can easily communicating that using particular channel, using that ROS topic or ROS messages. And now I think everyone got the basic architecture of basic working of ROS. And now I'm going to explain exact what this block diagram is. One node that is the right side, in the left side, is advertising its data into the master, and it's publishing the data. It's publishing the data in the master. And in the left side, there's a node that's subscribing the data. Okay, and master is controlling everything, or controlling each and every movement, each and every activation in the robot. Okay, like that, they get the publishing data, and one node is subscribing that particular data, and that node will perform the task. That node will perform the task for how the robot want to work. Right? Got it? I think all can understand this particular architecture. Also, one thing that I forgot to say is that inside the master itself, we can create different nodes. Like inside the we can create different nodes. Like we can create a node for controlling the actuation using a Python script or using a sensor data like that. We can create different node inside the master itself. But you don't want to confuse about that. You only want to think like this is a node, this is a master, and this is a topic. Only communication is this only terminology you want to learn if you are a beginner. There's a master, there's a node, there's a topic, there's a publisher node, there's a subscriber node. That's it in the ROS architecture. In the basic model, there is a lot of other things that we can explain using ROS topics, ROS messages, ROS services. A lot of things is there, but if you are a beginner, don't want to bother about everything. Or only want to bother about this terminologies. ROS topic, ROS publisher node, subscriber node, ROS master. That's it for if you are a beginner and you want to get started with this particular terminology. You can get started with this particular terminology itself. Yeah, I think all of you get the basic idea about how ROS is going to work. Yeah, and now I give a small overview of installation of ROS. I would like to share my documentation. This documentation is available in Makergram blog. I will share that link in chat box. Yeah, this is a basic documentation on ROS. It's a part 1 documentation that I written, and I write everything from basic in this particular documentation, like how it's work, like that. And it's a publisher node, subscriber node, publishing a topic on that. You can get everything from here itself. If you are using, I'm a Ubuntu lover, so I'm doing everything on Ubuntu. I'm not doing anything on Windows for building robots like that, and only I'm using Windows for presentation and designing, and for else everything I'm using Ubuntu. So I would like to start with how we can install, how we can which version is most stable for to get start and get more idea about ROS like that. If you are going to install ROS on Ubuntu 16.4, you want to install the kinetic version. So version, there is different kind of version. Kinetic, the alphabetic order, like the alphabetic order is if we going to the right side to Z, the newer version like that. Kinetic is an older version. Melodic, then Neotic. Neotic is the latest version that's available now for ROS 1. Yeah, if you are using Ubuntu 18, want to go for Melodic. If you are using Ubuntu 20.4, want to go for a Neotic version. Sorry, on the let it charge. Just a moment. Sorry for inconvenience. Just a moment. Yeah. Just a moment. Yeah, sorry for interruption. My laptop got drained. That's why. Yeah. In my case, for documenting this particular documentation, I'm using. I was used Jetson Nano for this particular thing. In that, I'm using a 18.4 Ubuntu version. and so I installed ROS melodic version. Everything is crystal clearly written in this particular documentation. I already shared that link in the chat box. You can access this documentation. Only thing you want to look after that, which version of Ubuntu you are using. If you are using 16, want to go for kinetic. If you are using melodic, if you are using 18.04, want to go for melodic. If you are using 20.4, you want to use melodic version. And this particular documentation is based on Ubuntu 18.04. So in this particular documentation, I was installed melodic version. So someone is using Ubuntu 20.4, want to go for 20.4 version that's already available in ROS wiki, and just follow that particular instruction. And also some code is only different. Some code like which file I want to source, and like that. There's only small changes in the installation procedure. The procedure is same. There is only small change in the command, or different between the version. Yeah, for being understanding. Okay. Basically, this is an open source platform. I already said that. There's a lot of problems and a lot of issues when initially the ROS was built. Each version is updating, like solving most of the issue and giving most of the support like that. One of the version is melodic version is supported by Python 2, and melodic version is supported by Python 2, and Nordic version is supported by latest version Python 3, like that. When the other parameters like Python, what all changes are going to happen, will happen, and that all changes made into the newer version, like solving the previous bugs, and they are releasing newer version. And in the I forgot to say one thing too. In the ROS, there is the real-time, not real-time operating system. ROS 1 is not a real-time operating system, and this was tackled by ROS 2. ROS 2 is ROS 2 tried to tackle the lack of real-time response or real-time operating system in ROS 2, like lack of real-time, like I want to say, I don't know, just lack of the real-time system were addressed by ROS 2, and this thing was solved by ROS 2. And ROS 2 is an industrial grade ROS. Like for example, we can use that in industry because it's a low latency ROS that even comes to ROS 2. The beginner understanding, when we goes to newer version, the problems and bugs are more fixed and more crystal clear ROS is available in the newer version. That's the main advantages in the if you are going to Nordic, the community support is much high comparing to the kinetic version because it's a new version and most of the bugs were fixed in last two versions like that. Am I clear? You are clear, Salman? Is my answer? Yeah. Okay. Thank you. Yeah. Like this is a basic. Everything is similar in all installation, but only thing is that there is some change in if you are installing. Just one. Yeah. If you are installing the ROS melodic version, you want to use ROS melodic. In the case of ROS Noetic, want to sudo apt install ROS Noetic for desktop like that. And also there is some change in Python libraries like that. That's only. And also I would like to explain what all different versions are available in each and every. So what all different packages are available in each and every ROS. Like there's a full desktop version. There's a desktop version. There's a base version. There's you can see that three different things when you go to install the ROS. Basically, in the full desktop version, you're available with a lot of libraries, 2D simulation, 3D simulation, and prediction is everything is available in the ROS melodic version, ROS melodic full desktop full version. Like RVS is the, Gazebo is the, and every simulator is the in the ROS full desktop version. I will explain what all simulation are work and how it work. I'll explain the next slide in my Google slide. And I just going through what different in each thing, ROS base, ROS full desktop, and ROS base. I'm going to explain that particular thing only. If you are going for the installation of the ROS desktop, it's only available RQT and RVS and the robotic generic libraries. For example, the keyboard, teleoptics keyboard libraries, camera libraries, like that only. If you go for the base version, can install. Sorry, I don't know actually about that. I'm not aware about that. I am not aware about that. Sorry for that. I will refer to my friends and I will answer that question in the Discord. Okay, is it okay? Is it okay? I think I'm audible, right? Yeah, okay, thank you. Yeah, I'm not aware about that. That's why. I will ask my friends and clarify that in the robotic channel in our Discord. Yeah. When it comes to ROS base version, it's a lightweight version, and that we can there's no GUI for that. Else everything we have GUI like simulation world like that. Everything is available in both the desktop and full desktop version. And there's only command line in the case of ROS base. Why we are using these three versions? Like you are confused. Like I want to install the full desktop version in my own Raspberry Pi. If we are going to install that on Raspberry Pi, there sometimes the Raspberry Pi may got blast because it become more heat, and it's not a lightweight thing. The ROS full desktop version is not a lightweight thing; it's a heavy thing. So we can't able to install that on Raspberry Pi. But I try to install ROS full desktop version on Jetson Nano, and it works smoothly. And I tweet that in 2 months before in Twitter, and it was smoothly working. The full desktop version is smoothly working on Jetson Nano, 2 GB Jetson Nano. Yeah, basically, if you are you a beginner? Tanvir, are you a beginner? Yeah, okay. So I would recommend to start with ROS melodic or ROS kinetic, or ROS pneumatic, because there is less support for ROS 2 now, and it's an emerging thing. So I suggest that you can go for learning ROS in kinetic or sorry ROS melodic or ROS pneumatic, and that have. Oh, okay. Oh, okay. What you will learn exactly, what all thing that you will learn in that course? Can you please briefly explain? So I can answer your question in a clear manner.
Yep, I think you can unmute yourself. You would like to talk. Yeah.
Yeah.
Zain, I think we can continue the Q&A session at the end.
Okay. Yeah. Basically, what I understand from his question is, yeah, okay. What I understand from his question is how we can use ROS2 on our microcontroller on our processor. We can install that directly from the ROS website or by referring a lot of other documentation. And it's available on ROS Wiki itself. We can install that package on top of our operating system. And we can install our packages and everything on our Linux command line itself. In this particular documentation, I only explain about ROS melodic version and ROS 1 example. And in this particular documentation, I didn't mention anything about the ROS 2 documentation. Sorry, ROS 2 workflow or ROS 2 installation. So if you are going to learn, if you are going to install the ROS 2, I suggest it will be too hard to get everything fixed and everything solved. Everything you want to learn from there, or everything is not documented well. So I suggest if you are going to learn deeply, start with the ROS pneumatic version or ROS melodic version. That's my suggestion. And you can install similarly like this similar manner. Like you say, you can use your Linux command line and you can install, you can copy paste this particular codes and particular line of commands, and you can install it and you can use that. Okay. Yeah, this basically how we are going to install that library and that package and everything. and want to make a workspace that we are going that like similar to the, if you are using VS Code or if you are using any Eclipse or for programming, want to make a workspace similar to that. Want to make a workspace for ROS 2 for keeping all our program, for keeping every packages like that. Yeah, that's it. Want to in the case of installation, want to main thing want to focus is which version of Ubuntu we are using, and which version we are going to install, full desktop or base or desktop version. Next, which workspace we are going to install. There is, I think there's some other workspace too other than Catney workspace, but I suggest Catney workspace because there is a lot of support in the case of Catney workspace. So if you are a beginner or if you are a learner, from starting from the beginning, I suggest start from the to start from the Catney workspace itself, because that will be much simpler to start your working and start your programs, everything. Okay, that's about the installation of ROS. So then I would like to say about simulation. And I forgot to mention one thing in the case of why we are using ROS. If we are building a robot from basics, from designing and everything, we can't able to identify what problem we are going to face in the case of manufacturing stage. If you are building a robot, its CG, center of gravity, center of mass is not exactly the center position. Sometimes our robot may topple, right? Sometimes our robot may topple. That's a small example that we can solve using simulation world. So Gazebo is a online simulation, ROS simulation world. There's mass, there's velocity, there's gravity, there's every physics that's available in the atmosphere itself. Okay, so if we keep a robot in air, it will fall down to the ground level of our environment itself. Like if we create our robot with varying center of mass, if my robot want to stand like this, like similar to this, want to horizontally to the surface. If my center of mass is varied, like if I keep a high mass in this side, our robot will topple to the side in the simulation world. So we can identify that if I keep this much mass in this side, our robot may topple. So that will be much easier when we go to the manufacturing stage. When we go to manufacturing stage, we can identify each and every problem, and we can fix each and every simple and small issues in the simulation world itself. So it will be much help for all beginners or learners to start their work, because we don't want to invest more money or more time on building our real hardware. We only want to invest a little bit of time in the case of simulation, in the case of software side only. So the advantage of simulation is we don't want to go for a real manufacturing thing, and we can solve each and every problem in the simulation world itself. Also, I will share a small simulation world that I made using ROS. There's a exact similar robot that is Studio Shieldport version 1.2, and it's an exact similar design that I made using SolidWorks. Using SolidWorks, I designed this particular robot, and I generated a URDF file. It means Universal Robot Description file. We can only use that file to simulate our robot in the Gazebo simulation. We don't want to bother about anything about that. What is URDF? What all things? How it's work? Like that in this particular session. After completing this session, you can go through this particular documentation. Everything is clearly documented in this particular documentation. Okay. So we have 3 links here. Yeah. Yeah, in here there's a base link. Base link means our chassis, and that's a base link. That's a base link, and there will be 3 child for that base link. That means one wheel, this wheel, and another wheel, and that caster wheel. That all are child, and that under this particular chassis. Basic chassis is the mother or base link. On top of that, we are using some other child to that particular robot chassis. I think you got it. there's a base, there's a wheel 1 and wheel 2, and there's a caster wheel. After that, want to fix the threshold value of like how velocity want to actuate like this, how effort want to, how torque want to generate in each wheel like that. We can fix each and everything in the SolidWorks URDF generator software itself. You can also see that there's a under limit, lower limit, and upper limit. That's in radian, right? If you are using building a manipulator, the manipulator will be moving like this. There's a rotary joint or a prismatic joint. Rotary joint means it's a rotating joint. Prismatic means it's a moving joint like this. So if you are building a rotary joint, we can set limit, like if you are limiting our robot from pi to pi by 2. In other case, pi by 2 to pi, or 90 to 180. That's a easier way to understand. If you are moving our rotary joint from 90 to 180, that's a limit of our robot. When it's converted in radian, there's a particular value come, and want to fix, we want to type that value in the lower radian and upper radian. The lower radian will be lower limit will be pi by 2, and the upper limit will be pi. That means 90 to 180. Our rotary joint want to move from 90 to 180 degree. That's it. That's a upper and lower limit that's in here. And there's a position for our particular wheel or our particular link that will be mentioned here. The position, the center of gravity, which type of joint it is, continuous or fixed joint. Continuous joint means it's a, for example, wheel is a continuous joint, caster wheel is a continuous joint, but base link is a fixed joint. Sorry, okay, got it. Base link is a fixed joint, wheel is a continuous joint, caster wheel is a continuous joint. Okay, continuous means it's continuously varying state or state of motion. That's about continuous joint. Okay. After that, want to generate the URDF, Universal Robot Description file from the SolidWorks, and we can source that particular. So we can copy that Universal Robot Description to our workspace, and we can build our workspace. Okay. After that, when our robot come to the environment, we can see that the robot will be like this. If all our parameter is correct, the robot will be staying horizontally and without any error. If my CG is varied, my robot right wheel or left wheel may got upside and like that. It not will be a clear manner like this. Okay. You want to make some changes in the Gazebo simulation itself. All things that I mentioned here, I'm not going to explain all those things, because there's sometimes that may make a lot of doubt, like how it works. When my communication is not properly, you will get some extra doubt, like you will not be clear exactly. So I suggest that go through this particular documentation, and you can grasp each and every point that I explained. Okay. After this, you can see your robot like this. Already explained about the teleoptic keyboard, right? I'm using that particular library to actuate my robot. If I press I, the robot will be moving forward. If I press J, the robot will be moving left. If I press L, the robot will be moving right. If I press K, my robot will be stopped. Okay, similar to that. Okay, that's a particular that's exactly the teleoptic keyboard library is working. Okay, and also I'll show the basic demo that I did. Yeah, my robot is working perfectly by varying speed, by varying the direction. There is no any error if I build this robot in a chassis, or if I 3D printed the robot, there may be no errors in the dynamics or kinematic side. Okay. My robot can work perfectly in any environment, like similar to the our environment. Okay. Atmosphere, similar to our atmosphere. In this particular environment, we have physics like gravity. We have moment of inertia. we have speed, we have velocity, acceleration, everything that in our atmosphere is there in that particular simulation. Also, we can bias that using some sort of codes in that particular software, because if you are building a robot and that into the mass, the atmospheric parameter is another. So we can fix that, we can change those parameters in the software, and we can use the mass atmospheric parameter into that particular simulation world, and we can simulate our robot. So we don't want to go to Mars and test our robot. Okay, we can test that particular robot in the computer itself, or in the PC itself, with each and every parameters that's happening in the atmosphere. Okay, so all about installation and Gazebo simulation. Okay, and I don't explain how we can learn this particular ROS. Okay, I would like to share. I already shared a documentation written by me, and also I will be sharing another documentation this way. This is a Husky robot. This is a nice documentation that I read. Also sharing this in the chat box. The link is available in the chat box. Okay, you can refer to this. Also, you can refer ROS wiki for learning your or beginning your ROS learning. Okay. Also, I will explain some sort of instruction in the ROS document, official documentation. There's an installation, introduction, installation, and getting started thing. Everything is available in the ROS itself, ROS official documentation itself. If you are going to build a small robot using Arduino and your PC, or using in processors like Jetson Nano or Raspberry Pi, I suggest like first start with installing. Then you just build small topics like you just go for the ROS serial, like say using Arduino or any serial communication device. There is a support for Raspberry Pi, Arduino. There is support for Teensy. There is support for STM32. There's all boards supported by ROS directly for building robots. Okay. You can use, I suggest go with the Arduino from beginning, because for Arduino, there's a lot of documentation available in Google, and also I will be posting a documentation on ROS serial soon in 2 weeks or 3 weeks, and I will be posting a documentation using ROS serial using Arduino. Okay. I suggest first you learn a little bit of on Python, a little bit on C++, and a little bit on Arduino, and a little bit on Ubuntu command line. Yeah, that's it. Okay. We can get a recorded video. Which recorded video?
So Zain, I think he asking about the Zoom recording
video. Okay. I think
that will be shared in the Discord channel.
Yeah. If I also need to say another thing. If you are begin with the learning on ROS, like if you install the ROS, first design a robot on Fusion 360 or SolidWorks, and simulate that in Gazebo Simulation. It will be more, you will get more understanding how ROS work, how you can get the how you can communicate. You can communicate using each node, and how the master is working, how the ROS core is working. Everything will be cleared when you build a small robot and simulate that in Gazebo Simulation. Okay, and you can also familiarize with teleoptics keyboard. You can familiarize with many other packages too. Okay. Also, if you are building a robot, want to map a particular area and want to perform a particular task, so we can use LiDAR, we can use depth camera, like that. Okay. For that, every package is already available in Google. Okay. If you are going to map a particular room, the LiDAR library is already available in ROS official documentation itself. So only need to source that particular documentation into your GitHub, into your workspace, and you can use and you can explore using that. Okay. We only want to work only on your innovation side. Okay. Got it? That's the only thing you want to work on top of that particular thing. Okay. Now, I would like to show a official video that by ROS itself. This may clear all your doubts that I explained. This video is audible, right, Salman?
No. Can you play? Please play.
Is it audible?
Not yet. Yeah. No.
No. Okay. Just a moment. How I can do that? Anyone can help me with audio?
Share with your share with sound as well. So maybe you can try to share.
Ah, yeah. Okay. Oh, yeah. Okay. Okay. Share sound. Okay. Got it. Got it. Yeah.
Building robots is difficult.
Is it audible now?
Motors, sensors,
Yes,
software, and batteries.
Yeah. Okay. This is an official video by ROS itself.
Building robots.
Sorry, a small network issue from myself.
Allahu Akbar, Allahu Akbar. Allahu Akbar,
Sorry for the inconvenience. I will share the video in the chat box because there is some issue with my network. Sorry. Is it okay?
Yeah, sure.
Yeah,
that's
okay. Yeah, okay. You can refer this particular link and you can see that particular video. After seeing that, you will be clear with how we can perform each and every task using roles. Also, I would like to explain one more thing in between. If we are building a manipulator that for industrial purpose, want to fix, that's in supply chain, for example, that's in supply chain. Want to take a box, take a particular box, in particular box. Like for example, I got a gift from Seed Studio. Okay, I got a gift from Seed Studio, and another all box are from different companies and different organization. So on top of that Seed Studio box, there's a label Seed Studio. There is one camera on the end effector of that particular robot. End effector means the task performing area, or a grabber or a gripper. That's a end effector. That means the end effector. Okay. On top of that end effector, there is a small camera. That camera will be identifying which box is from Seed Studio. Okay. If that particular package is getting near to this particular prismatic arm, then the arm can take that particular package and place it in another box. This task can perform by using ROS easily, because I will explain how we can perform that particular task. We only want to install that camera package, and that's already available in the ROS package. Then we want to install, design I'm not familiarized with Robo Analyzer. Sorry. Can you please explain what Robo Analyzer is? That will make many of them aware about that.
Hello,
Yeah.
may I say something?
Yeah, can you please explain what Robo Analyzer is? I'm not aware about that. And some of another.
Yes, I have used this software recently for the simulation purpose of the 3DOF robot. And there we can make one robot with different types of joints, like prismatic joint, revolute joint, different joints, and 3DOF, 4DOF, different types of DOF types of robot can be made. And this is basically for the robotic arm only.
Oh, okay.
And with that design, we can get the DH parameter matrix also. And this is for the simulation purpose. And after that, we can get the information about the all those link length, joint angle variables,
Okay.
different types of all these things, all this information we can get, and we can build one hardware robot with those information as per our requirement.
Oh,
So
okay,
this
cool.
one I have used recently. So can we use this one? I mean, whatever you are showing here
Yeah.
with the same purpose.
Yeah, this same purpose. But in the case of, as you said, the robo analyzer is only specifically for manipulator, right?
Yeah.
Yeah, but in the case of ROS, we can simulate any kind of robot. Like we can simulate drone, we can simulate differential ride robot, we can simulate manipulator,
Okay.
we can simulate like skid steer robots, we can simulate omni robots. Any kind of robot we can simulate in the ROS simulation. Like RV simulation is available and the Gazebo simulation is available. Gazebo simulation is mainly using in the initial stage. After manufacturing the robot, we can use the RV simulation to get the live performance of our robot. Okay, I think you are clear, right?
Yeah. This is
Yeah.
more advantageous, I think.
Yeah. We can use any kind of robot, and we can use both both manipulator and omni robot or definition robot at the same time inside the gazebo. Okay.
Yeah. Okay.
Yeah.
Thank you.
Okay.
Thank you.
Yeah.
Yeah.
Thank you for sharing the knowledge. Okay.
Okay.
Yeah, that's a main advantage of ROS. So we can simulate any kind of robot, any kind of activities, any kind of motion in the ROS environment. Also, we have a lot of community support for to solve our problem. For specifically for ROS, we have a questionnaire platform called ROS Answers. If we put any of our question in ROS Answer, the community will answer. Community guys will answer. And also, if I know the answer, I can reply for that. Okay. Similar to the Ask Ubuntu, like that. Okay, working like that. We have a raw census. We can put our questions in raw census. It will be replied immediately because a lot of guys are working on that particular platform. So, and we can use that particular platform for build many kinds of robots. Recently, in our state, Kerala, there's a robot built to our medical college for medical purpose. That basically work based on ROS. Okay. Also, there's a drone built in my college, in my university. That basically it's working based on ROS. So each and everything we can simulate on ROS directly. There is no any interference. There is no any problems. There is no any problems if you are simulating our robot. If you are working on top of the ROS, on top of the ROS. Also, when I work on ROS drone simulation, the easiest thing that I got is I can integrate the camera on our robot, our drone, and we can visualize that particular camera visualization on mission planner directly, and we can connect the mission planner. That mission planner is used for drone. That's by Autopilot. It's an open source platform. Okay, I can visualize that particular drone, where the drone is going. Like that, I can visualize that graphically in the mission planner too. That will be too cool when I go with the ROS and ROS simulation. Okay, that's it. I think some of you get some knowledge about ROS, and some of get you inspired. Like I can get started with ROS. And also one thing I want to say is ROS is too simple if you are in right path of learning. Okay, I suggest don't go directly with the ROS wiki documentation. That will make you disturbed because that's too. If you have a if you all clear all the prerequisites, then only I suggest you can go directly to the ROS wiki documentation. Otherwise, you can refer my documentation or also share another documentation that robot of Husky. Okay, you can refer both those documentation. Also, you can ask your queries in the Discord channel, robotics channel. Okay, I will be answering all. Also, the all. I'm not a master in ROS, or I'm not a full knowledge in ROS. All other can also answer if they know and the answer. Okay, that's it, and I'm including my words. Anyone have any more doubts? If any more doubts, I can clear if I know.
Yeah, thanks, Zain. Thanks
Yeah,
for the
okay.
session. Thank you so much. And
Okay, welcome.
we are starting the Q&A session. So if you have any doubts regarding the ROS, particularly, please ask. We have 5 minutes space for that. And also I share the link for the community. You can join and Zain will be available there, like as per his free time. And he will try to answer your question, and also other members also there. So
Yeah, there's a small minute, 1 minute.
yeah, sure.
There's one question that asked from one guy. We can install the ROS on AWS, right? I will be answering that on the Discord channel. Okay. Yeah.
Is that good? Yeah. Okay. So Susmita mentioned about collaborative work. Yeah, I would like to share a bit about academy that we are working. Please for a bit. Okay. So I think I can share my screen. Or Zain, can you share your screen and show our like Discord group?
Yeah. Okay. Sorry, I'm not installed the Discord in my Windows machine. It's only in Ubuntu. Okay.
Yeah, sure. So
Sorry.
Vincent, can you please give me the permission to share my screen? Yeah, now it's yeah, cool. So I am able to share my screen and share in a moment. Okay. Okay. Yeah. Oh, where's the screen? Okay. Meanwhile, if anyone have questions, they can ask. Okay. So I think you can see my screen, right? Is it visible? Zain?
Yeah. It's visible.
Okay. So I would like to share about our community called Academy. So Academy is an international community that more focused on like collaborative learning, collaborate, project building. So Academy, the name actually you might like it's a bit different, right? So it's actually Academy plus Academy. So together we are learning things. We are like collaborative. Like what we can call like right now the Zain is actually sharing the fundamentals of ROS, and he's actually sharing these expertise through us, right? So similar to that, we actually organize different kind of events. Like last Saturday, we organized a LoRa event, particularly helium events, and we also have a few events actually upcoming. Like 2 days, we have actually have a KiCad sessions, and also here you can see. We have a TinyML learning group, so tiny machine learning group. So what we are expecting here is you can join here, and together we have a syllabus, and we can actually together build project focusing on TinyML. And don't worry if you are a beginner or you don't know about the technology behind the TinyML or anything. We actually going to learn together. Okay. So right now what you need to do is you just join the Discord, and you can explore the different kind of channels here. And first you just need to like introduce yourself, and feel free to use like gifts like this, no worries. And you can find different kind of channels like opportunity channel for online competitions, contests, etc. And upcoming events actually listed here. And you can also like find project partners, like if you are interested to do a specific projects, and if you want to find members to join the specific project, you can ask and you can post here. Or if you don't have any idea but you would like to join a project, you can also post here, so somebody will like try to invite you in a specific project. So we have a specific sessions for that, etc. So that about our community, and we will share the links and other details, like already share the community Discord details here, but we will try to share more details about via your email ID as a newsletter also in coming days. Yeah. So that's about our community. Like if you have any questions, you can feel to ask here, or just share here. If you don't have any, that's also no issues. You can share on the Discord as well after when you further doubts. No worries. Like anything to add, Vincent?
Just a moment, Salman. Can I interrupt?
Yeah, sure.
Yeah. Tanvir asked a question that I'm pursuing BTech in mechatronics. I want to go in the field of robotics. Please suggest me. I think Susmita ma'am can answer that particular question, right, Salman?
Yeah.
Yeah.
I think Tanvir, can you please ask the question on the Discord so we can continue the discussion?
Yeah.
Because,
Right.
the Zoom chat will be discarded after we close the event. So
Yes, right.
helpful if we add the question on the Discord. Is that good?
Hello, may
Yeah.
I ask one thing?
Yeah, sure.
Yeah, sure.
I have a question that if in this group, if the students are going to start any new project, new kind of project with some recent recent problem statement from the MHRD. So is there any option for the startup with those new projects, with the real-time problem solving part?
Problem starting is actually as a community we are providing mentorship support for free, like in our Discord different we have different disciplines of members like who was working as a professional in a long time, like embedded professionals, etc. And also we have students and beginners also. So mostly we provide like online mentorship support that you mentioned, right? So what are the support?
Mentorship is there, it's okay, but I'm telling about the startup relations. I mean after building the projects, what is the future of those projects? Are those market ready, or they can build their own entrepreneurship skills like this? Is there any option like this?
Yeah, that's actually an interesting question. Currently, we don't have such a program for incubations actually, because we don't run as an incubation, but we can connect to industry experts like Real Tech, Media Tech. We can connect you to them, but we don't run our own incubation yet. But that we can discuss on Discord how we can support, or we can share. We know like different parties that who run incubations, who run startups. So we can try to share the information to the participants who is working on the projects. But we can't directly support right now due to our bandwidth.
Yeah, I can add some points here. Is that we have economy has a good network from like semiconductor companies or like platforms like Hexter, like the platform like Edge Impulse and some scholarship partners. So I think we have lots of different kind of alumni from different kind of industry area. So if you want to find and get matched with different kind of industry mentors, feel free to reach out and speak out. And we will try our best to connect all the networks we have. Because the original idea of having economy is that we don't want people doing project and doing self-learning people feel lonely and people feel it's so hard, but we want to like encourage everyone to like start their ideas and get help and accompany each other on the learning journey.
Yeah, so thanks Paul for adding this. So I think anyone have any other doubts? I think it's all set. Thanks for the wonderful session by Zain.
Also, thank you for inviting me to such a platform. First time in the international platform to speak out.
Well, it will be a start.
Yeah, it's in my college days itself.
Nice. So yeah, thanks
Thank you,
for the So I think we can wrap the session, right? Everything good? we can meet. The event is not going to end. You can start the start the discussion on the Discord as well, and it's not limited to ROS, but you can ask about more anything about making hardware, electronics, etc. So yeah, you can close. Thank you everyone. Thank you for joining, and thank you for asking your question. Thanks for your participation. Have a nice day. Bye bye. See you.
Bye. Good night.
Okay, bye.